Hey everybody, so today we're going to start the 2016 Mcas, which is a retro Mcas. It's in the previous format, so the problems are going to be significantly easier and, I don't know, I think they're a little less challenging. But still, I think there's a lot of value because the content is the same, it's just the presentation is significantly different. Okay. So we're going to jump right into it. Before you watch this video, you should have already tried this section. I don't know how far we're going to get. We're going to try to get some of the problems done, but the PDF to this document is found in the video description. So you should download that, print that up, try it out first, and then watch this. Let's get right to it. And you'll see this is the non-calculator section. And we're probably going to need the, actually, let's see if I can fix this autofocus real quick. Oh, there we go. Okay. So there is a document sheet at the end, formula sheet at the end. So we're going to be using this. All right. So a cube has a volume of 725 cubic centimeters. Which of the following is closest to the length of the edge of each cube? So let's look at the volume formula for a cube. So volume formulas are right here. Cube is V equals S to the third power. S is the length of an edge. Okay. So V equals S cubed. I'm going to shut those doors because my neighbors are being loud. Okay, much better. So V equals S cubed, which is the length of each edge, and we're told that the volume is 725 equals S cubed. So what we need to do is take the cubic root of each side of this equation, and that's something a lot of people don't remember or they haven't seen in a while. So the cubic root, so we're going to get rid of that, so this is going to become, it's one of these three numbers. And it says closest to. So I don't know what the perfect cubes are, but we can just try these out by multiplying them by 3 times. So S equals the cube root of 725. And I don't know what that is, but we can figure it out. So let's try each of these out. So 7 times 7 times 7. So 7 times 7 is 49. And 49 times 7 I'll put over here. So 7 times 9 is 63. Carry the 6. 7 times 4 is 28. 28 plus 6 is 34. So 343. No, that's definitely not it. Let's try 8. So 8 times 8 times 8. 64 times 8. And 64 times 8 is going to be, let's see, 4 times 8 is 32. 6 times 8 is 48, plus 3 is 51, so 512. Probably not, but let's put 512 here. And then 9 times 9 times 9. So 9 times 9 times 9. 81 times 9. And 81 times 9 is going to be, let's see, 9 times 8 is 72. So 729. And that's very close. This is actually going to be further away because it's going to be 1,000. So it has to be C. So we actually didn't end up using the formula. We're probably better off just plugging these in, but it's probably good to see the formula and see how it works. All right, which of the following is equivalent to the expression below? So we have a binomial combining with a binomial. So this is plus, so we're going to rewrite this without any parentheses. So 3m squared plus 4 plus 8m squared minus 5m. So let's combine the terms. So 3m squared will combine with 8m squared. They're both positive, so it's going to be 11m squared. We have minus 5m, and then plus 4. So there we go. So it looks like here people made mistakes and combined terms together that weren't supposed to be combined. I think that's the only way I could see somebody messing that one up. Number 3 is a scatter plot problem. A scatter plot below shows the relationship between the grams of fat and the grams of protein in the sandwiches sold at a deli. So grams of protein is the y-axis and grams of fat is the x-axis. Based on the line of best fit for the scatter plot, which of the following is closest to the expected number of grams of fat in a deli sandwich is 10 grams of protein? So we're looking to see what the probable x value would be when the y value is 10. So we need to make a line of best fit. Now, this one is kind of interesting because this scatter plot, you want it to be best represent the data, and this point is the one that's going to cause problems. So I'm going to go with, actually, I'm going to have a pencil for this, because I may want to erase this. This is actually harder than people realize, this problem. say it's more like that one. Yeah, this is a little tricky. I might be making a mistake on this. This one's kind of one of the ones I didn't really care for. Because ideally, well, here's what happens. A lot of people want to, they automatically want to have the line of best fit start at the origin. And this one kind of tempts you to do that, but you don't want it. It's not always the best case. It's not always where it belongs. So we're going to go with this. For now, I think that's okay. All right, so 10 grams of protein is here. So it would be right around, let's say here. So it would be 7 or 8. 8's probably close enough. Yeah, right about there, which comes out to be right around 8 on the x-axis. Okay. Number 4. Which values of x and y make the system of equations below true? So this is a system of equations problem. I think elimination is probably our best bet. So let's go ahead and change all these signs. So we're going to distribute this negative sign. So let's rewrite that over here. We're going to say 2x minus y equals negative 1. And then negative 3x plus y equals positive 3. We just changed all those signs. So 2x take away 3x is going to be negative x. These cancel out. And then negative 1 plus 3 is going to be 2. And then we're going to get rid of our negative 1 coefficient by dividing both sides by it. And we're going to have x equals negative 2. And it looks like it's going to be b, but let's just plug it in to make sure we get negative 3 for y. So 2x minus y equals negative 1. 2, we're going to plug in negative 2 for x. Y equals negative 1. 2 times negative 2 is negative 4. Minus y equals negative 1. We'll write that over here. Actually, we write that over here. Negative 4 minus y equals negative 1. We're going to add 4 to both sides. Negative y equals 3. Divide both sides by negative 1 because that's our coefficient. Oops, hold on. Put the minus sign there. And y equals negative 3. So yep, negative 2, negative 3. If you weren't sure, you could also plug them both in, but they both work. All right, so number 5. Which of the following is equivalent to the expression below? So this is just making sure we know how to do distribution. So negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. So negative 3x plus 6, which is right here. Okay, number 6. A total of 29,183 votes were cast in the election. The winning candidate in the election received 61.3% of the votes. Which of the following is closest to the number of votes received? So we're estimating here. So we're going to round this up to, I don't know, 30,000, I guess. 29,000. We'll do 30,000 for now. And round this to 60%. So we want to find 60% of this. So, no, yeah, we're going to do this 29,000. Just, yeah, trust me. I don't want to round that far up. And this is 60% of that. So 60% of that means we just multiply this as a decimal by that. So 29,000 times 0.6. Okay. We're going to multiply that by 0.6. All right, so 0, 0, 0. 6 times 9 is 54. Carry the 5. 6 times 2 is 12. This 5 is 17. This is one decimal space. This is 17,400, which is awfully close to 18,000. So B. Okay, number 7. The sum of the lengths of any two sides of a triangle must be greater than the length of the remaining side. This is true. Triangle inequality theorem. The lengths of two sides of a triangle are 8 and 13 inches. Which of the following represents x, the possible length in the remaining sides? Okay, so really simple, this problem. When you're given 2 of the 3 sides of a triangle and you need to find the range that the third side could be, you're going to add them and subtract them, and that will give you the range, the high and low value. So 8 plus 13 is 21, and 13 minus 8 is 5. So it has to be greater than 5 and less than 21. So just like this, which I believe is right here. It has to be an and statement. Okay, and that's it. Number 8. What is the value of the expression below? So this is order of operations, and I like to remind myself with the following acronym. I think this is the best way to remember it. This one, not a fan of, and I'll show you why. If you try to remember order of operations like this, it gives the impression that you always multiply before you divide, which is not the case. Multiplication and division is a single step from left to right. So there are instances when you're going to divide before you multiply. And I think this acronym, I think it causes problems when it's displayed like this. So we're going to look for our P, which stands for parentheses. We have parentheses. We're going to do things in there. And you still use the following order. So do we have parentheses inside the parentheses? Yes, we do, right here. So we're going to do that first. So 3 take away 5 is going to be negative 2. So 80 divided by 6 plus negative 2 times 2, close parentheses. Okay? We still have parentheses, and we have addition and multiplication. So we're going to do multiplication first before addition. So negative 2 times 2 is going to be negative 4. So we're going to write 80 divided by 6 plus negative 4. So there's still parentheses here. So 6 plus negative 4 is going to be 2. So 80 divided by 2. And 80 divided by 2 is going to be 40. That's D. Okay. The height of the right circular cylinder P is twice the height of the right circular cylinder Q. The radii of the cylinders are of equal length. What number times the volume of cylinder Q is equal to the volume of P? All right, so here's what we're going to do. The first thing we need is the formula for the volume of a right circular cylinder. So let's take a look at the formula sheet, which is right here. So volume, right circular cylinder is right here. So V equals pi times r squared h. So V equals pi r squared h. Okay. And we're going to do one for each of these two. We have P and Q. So P. All right, so P is going to be twice the height of Q. P is twice the height of Q. Okay, so Q is a smaller one. So Q is going to be this one. Q is going to be pi r squared h. Now this one's h is going to be twice that length. So we're going to be pi r squared 2h. Okay? That's what it is. This is 2h. All right, no big deal. What number times the volume of Q is equal to the volume of P? So if I figure this out, I can actually, this is basically double that in terms of like what you're multiplying it by. If you multiply this by 2, it goes right here, and the order doesn't matter because it's multiplication, and multiplication is commutative, so it doesn't really matter. Yeah, it should be 2. All right, number 10. Point G, zoom out a little bit here. Point G is shown on the coordinate grid below. So G is down here. Point H is located in the shaded area of the grid. Which of the following could be the midpoint of GH? So H is somewhere up here, and the midpoint is somewhere over here, obviously. So, I remember that they did this one. This was actually, they did something like this digitally, this problem. So here's what we're going to do. We're going to plot each of these midpoints, and we're going to see graphically where they belong. Now, what you could do is use the midpoint formula. The midpoint formula is x1 plus x2 over 2, and that's y1 plus y2 over 2. Basically, you're finding the average of these values, and those are the coordinates of the midpoint. So what you could do is you could basically write 1 equals 7 plus x over 2 equals something. Sorry, 7 equals, my bad. 1 equals 7 plus x over 2. And you could solve for x. And once you found x, you could see if it lands up here along with the y. That takes a long time. We're not going to do it that way. We're going to do it a much quicker way, okay? So we're going to plot each of these midpoints, and we're going to track the rate of change and see which one would land in here, which is actually a lot faster. This pencil I need to sharpen. Hold on one second. Okay, pencil has been sharpened. So let's go ahead and do that. So 1, 1 is right here, right? So how far did that take us? We went 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4 up. Let's go 6 across. 1, 2, 3, 4, 5, 6. And then 4 up. 1, 2, 3, 4. Nope. So that doesn't work. So A's out. Let's try another one. You know what? Pencils don't really help if the eraser's not working. There we go. Let's try B. So 2, 0. So 2 zeros right here. 1, 2. Okay, let's connect those. So 1, 2, 3, 4, 5. 1, 2, 3. So 5 and 3. So 1, 2, 3, 4, 5. 1, 2, 3. No, just outside. So that's out. So I guess this problem, you need to understand how a midpoint works, but you also need to understand how rate of change works to make this a lot easier. 3, 1. 3, 1's right here. 1, 2, 3. Oh, why am I doing that before I connect it? 1, 2, 3, 4. And 1, 2, 3, 4. Okay. That's a rate of change of 1. Huh. Here we go. 1, 2, 3, 4. 1, 2, 3, 4. That one works. This is looking like it's right. Let's just check the last one just to make sure we didn't make a mistake. So 4, 0 is right here. And we're going to connect those. 1, 2, 3. 1, 2, 3. So 1, 2, 3. 1, 2, 3. Yep, comes up just shy. C is correct. So that one's a lot easier, in my opinion, if you do it that way. If you try to use the midpoint formula, I think it would just take way too long. Okay. Number 11. Which of the following is closest to the value of the expression below? So this is some rounding we have going on here. So we're going to convert this to 3. We're going to change this to 8. So now we're going to do exponents first. So this will be 64 times 3. And 64 times 3, let's find out what that is. So 3 times 4 is 12, carry the 1. 3 times 6 is 18, plus 1 is 19. So 192, that is closest to 200. So, all right. Okay. Number 12. Which of the following expressions has a value of 0? So let's find out. Let's just do all of them. So I'm going to write these over here. A lot of order of operations in the 2017. Or is this 2016? Sorry, yeah, this is 2016. So 2 minus 3 minus 2 minus 3. Okay, so order of operations again, I'm going to write this right here. P-E and M-D and S. We're going to do the work in the parentheses first. So 2 minus 3 is negative 1. And then 2 minus 3 is negative 1. These are going to become positive. So negative 1 plus 1, that's going to be 0. So it's looking like A. Let's check to see if the others, make sure we didn't make a mistake. So 2 minus 3 minus the absolute value of 2 minus 3. So you can treat absolute value like parentheses in terms of order of operations, but you cannot distribute anything into the absolute value. So 2 take away 3 is negative 1 minus absolute value of negative 1. The absolute value of negative 1 is 1, so negative 1 minus 1. This would be positive 1, but still, yeah, you get it. Negative 2. Boom. That doesn't work. That's out. C here, we're going to have 2 minus 3 plus negative 3 plus 2. So 2 take away 3 is negative 1. Negative 3 plus 2 is negative 1. And that's going to be negative 2. Last one. This is D. Absolute value of 2 minus 3 minus negative 3 plus 2. Absolute value of 2 minus 3. Negative 3 plus 2 is negative 1. And that's going to become, let's see, 2 minus 3 is negative 1. The absolute value. This becomes plus 1. Absolute value of negative 1 is 1. 1 plus 1 is 2. So, yep, A is correct. All right. Yeah, look at this. A lot of order of operations. Well, not really. This isn't order of operations. So which of the following is equivalent to the expression below? So you could factor this, but it's much easier, I think, honestly, just to distribute here and see which one comes out with this. So we're going to do that. So we're going to distribute that. So 5 times 5 is 25. 5 times negative 3x is negative 15x. And we're going to distribute these. 3x times 5 is going to be plus 15x. And 3x times negative 3x is negative 9x squared. These cancel. 25 minus 9x squared. So guess what? We got the answer. Let's just do one more to show you what it looks like when it's not going to be the answer. I'm not going to do all of these. So 3x times 3x is going to be 9x squared. 3x times negative 5 is going to be negative 15x. Now we're going to distribute this negative 5. Negative 5 times 3x is negative 15x. And negative 5 times negative 5 is positive 25. These combine together, we're going to get 9x squared minus 30x plus 25. And that's not that expression, so it is A. I'm not going to do the other two. A line passes through the point 5, 4 on the coordinate grid as shown below. Which of the following best represents the equation of the line? So this is a line with a constant rate of change. All right, it's horizontal. The vertical, the y value is not changing, so it's constant. Let's look at the y value. The y value here is going to always be what? 4. So y is always 4. That's not changing. Right here, y is 4. Okay. And I think we'll do these last two, then we'll call it. Yeah, we'll call it right before the open response. What is the value of the expression below? So we have the square root of 64 squared. Let's do order of operations here. So the work in parentheses means the absolute value. The square root of 64 is 8, and 8 squared is 64. Okay. A support wire is attached to a tree with a height of 9 feet. The wire is anchored in the ground as shown below. There's a right angle here, so we're looking at a right triangle. Based on the dimensions in the diagram, what is the length and feet of the support wire? So we're looking for the hypotenuse of a right triangle. And we're given the other two sides of the right triangle, so we can use Pythagorean theorem. A squared plus b squared equals c squared. And it doesn't matter which is which. We're going to call that a, we're going to call that b. So 9 squared plus 12 squared equals c squared, which is the support wire length. 9 squared is 81. 12 squared is 144 equals c squared. We add these together, so 144 plus 81 is going to be 12. Okay, we want 225. So 225 equals c squared. We're going to do square root of both sides. And I believe the square root of 225 is 15. Let's just make sure of that. I think it is, though. Because remember, we wouldn't have the calculator for this one. So carry the 2. 5 times 1 is 5, plus 2 is 7. And then 15. Yeah, it's going to be 225. I always forget that one. Okay, so 15 feet. Don't forget the unit of measurement. Okay, awesome. And then the next video we'll pick up with the open response. Let's check our answers. Let's see how we did. Okay. So number 1, we had, let's zoom out a little bit here. We had C. So number 1, and again, this answer key is at the end of the PDF. C, good, we got that right. 2, we have A. 2 is A. 3, we got B. 3 is B. Okay, 4, we got B. 4 is B. 5, we got D. 5 is D. 6, we got B. 6 is B. 7, we have A. 7 is A. Okay. So far, so good. Number 8, we got D. Number 8 is D. Number 9, we have A. 9 is A. Awesome. Number 10 is C. 10 is C. Oh, we're on a roll. All right. Number 11, we have B. 11 is B. 12, we have A. 12 is A. 13 is A. 13 is A. 14 is B. 14 is B. Then we have the 2 short answer ones. 15, we had 64. 15 is 64. Yeah, we got it. Awesome. And then 15 feet we got for this one. And 15 feet. Awesome. All right, so hopefully that was helpful, guys. We'll continue this probably tomorrow. No, not tomorrow. We have school tomorrow. But I'll make another video more than likely on Friday and try to finish off session 1. All right, thanks for watching, guys.